Hi everyone, this is Mrs. Musoff. Today we are going to be talking about how to graph a quadratic function. That's what this whole unit is actually going to be about, graphing quadratic functions. A quadratic function is a function that just has an x squared, so its highest exponent is a 2. Alright, x squared, nothing bigger than x squared. And the nice thing about graphing quadratics is they all have the same general shape. We just kind of move them around a bit, and that's where our transformations are going to be really helpful. Alright, but before we start graphing a bunch of them, let's start with just the parent function. Alright, the parent function is like our starting function that has no transformations. So in this case, that would be y equals x squared. Now, anytime you have an equation and you don't know how to graph it, I'm always going to start with a table, an xy table. And I'll use that to kind of give me an idea about what it's going to look like. Alright, now with my xy table, I like to choose x equals 0. And then I like to choose a couple negative numbers, so -1 and -2. And then a couple positive numbers. And all I'm going to do to find my y values is I'm going to plug them in. Because remember, I know y is equal to x squared. So I can find these y's by plugging -2 in for x and squaring it. Alright, now just be careful, -2 squared, that's like doing -2 times -2. So that should be a positive 4. Alright, same kind of thing with -1 squared, that's like -1 times -1, so that's a positive 1. Alright, 0 squared, that'll just give me 0. 1 squared will give me 1. And 2 squared will give me 4. So now I have all these points. I have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. So let's plot them. -2, positive 4, -1, positive 1, 0, 0, 1, 1, and 2, 4. And you can kind of see what it's about to look like. It kind of looks like a U. And that's kind of the general thing we're going to refer to it as. It's kind of like a U. Alright, not quite a V, because when we think of V, we should think of those absolute value graphs we did a few weeks ago. This one's a little different. It's a U. And actually, that shape, we have a name for it. It's called a parabola. Oops. There we go. Alright, and it's actually right there on that list of vocab words that we have to know. So that first word, parabola, is just the shape of all quadratics. All quadratics will have either this shape or it'll be reflected, so it'll be upside down. Alright, some other important vocab words to know. The vertex. Okay, the vertex is this point right here. But we've been calling it another name in our most recent unit. Do you guys remember what we would call a point that's like that right on the bottom? Hopefully you remember it as a min or a max. In this case, a minimum, right? But any point that's at the way bottom or the way top is a min or a max. So this vertex, another name for it, is just a minimum or a maximum. And in particular, this one, is actually an absolute minimum. And that's how all quadratics will be. Whatever the vertex is, it won't just be a min or a max. It'll also always be absolute. Since all quadratics look like this, they'll always have an absolute min or max. Alright, a couple other vocab words. Axis of symmetry, that is the line that goes straight through your graph. It cuts it in half. It kind of acts as like a mirror. So if there's one point on one side of the line, there should be another point the exact same distance away, right? Like this is 2 units away on one side, 2 units away on the other side. Alright, that's what an axis of symmetry is. Oops. And so I'm going to label this. I'm just going to write AOS. That's the shorthand we tend to use. And the equation is, since it's a vertical line, it'll be x equals. And this one, x is 0. So it's x equals 0. Alright, the last thing on here are x-intercepts or zeros. Remember, we learned about this already. These mean the same thing. And they're just the points where the parabola touches the y-axis or the x-axis. Alright, so let's try a couple examples that just kind of refers to this axis of symmetry and how important it is. Alright, so example 1, a parabola has an axis of symmetry of x equals negative 3 and contains the point 1, 6. Find another point on the parabola. With these types of problems, they can be kind of tricky, so I really like to draw it out. I think it helps a ton. And remember what the axis of symmetry is. It's that mirror line. So if I throw down x equals negative 3, that's like this dashed line. And I know my parabola happens half on one side and half on the other. So when it tells me this point is on the parabola 1, 6, let's see, I'll plot it 1, 2, 3, 4, 5, 6. So right here is 1, 6. What that tells me is that on the other side of this line, I'm going to have the exact same point. Because remember, this axis of symmetry, it kind of acts like a mirror. My parabola is going to look something like this. Alright, so if there's one point on the right side, there will be that same point on the left side. So that point is going to be at the exact same y value. So that's going to have the same y value. The only thing that's changing is the x value. And to find the x, you just have to figure out how far away it is from the axis of symmetry. For example, this one is, let's see, if I start here 1, 2, 3, 4 units away from the axis of symmetry, that means I want to go 4 away on the other side too. So if this axis of symmetry was at negative 3, I'm going to go 4 units to the left, 4 left, and that'll put me at the point negative 7, 6. Alright, so again, same y value, the only thing that's changing is our x value. Alright, take a look at example 2 and feel free to try it. If you check the filled in notes that are up on Canvas, you can check to see if you got it right. Alright, otherwise we're going to move on and talk about graphing a quadratic. There are 3 different forms that we could graph a quadratic in, and each form tells us something a little different. Alright, so we're going to start with vertex form, and just like the name makes it sound like, vertex form is awesome because it tells us the vertex without us having to use a calculator. Tells us vertex. And since the vertex is the most important point of a quadratic, that's kind of a big deal. Alright, now this formula might look a little familiar because it has to do with our transformations that we learned last chapter. Alright, so let's just run through them real quick. This inside number is the left or right, and it's always opposite. That's why the minus is there. This outside number here, that plus k, is our up-down, and it's always the same. And this a can mean a few different things. If it's negative, it means there's a reflection over the x-axis. If it's bigger than 1, it's a vertical expansion. And if it's smaller than 1, it's a vertical compression. Alright, so what we like to do is we like to use that information to try and find our vertex. Our vertex should always be represented by h and k, by our shifts, our left, right, and our up, down. So our vertex is going to be h, k, opposite, and then same. And then our axis of symmetry is just going to be x equals h, whatever that first number in our vertex is. Alright, the only other thing we would need to know is which way it opens. And by that we mean a parabola could open up or it could open down. Most of them should open up. The only reason it would open down is if there's a reflection. So it would open up if there's no reflection, and it would open down if there is a reflection. Alright, so let's do a couple examples. We can kind of see what it looks like. Go ahead and flip it over. So for this first one, graph f of x equals x minus 1 squared minus 9. So I can look at this equation and kind of see that vertex form in it. And so that's what tells me, oh, this is vertex form, so I should know my vertex without using a calculator. Alright, and we're also going to describe our transformations. So let's start with the transformations. Remember, we go inside first, and then outside left to right. Now, there is nothing for A, so I can skip that one. So I just have 2 transformations here. Inside is my left, right, but it's opposite. So that'll be shift right 1. outside is up, down, but it's the same. So that'll be shift down 9. Alright, and that should kind of tell you our vertex. Because remember, normally the vertex will be at the origin, 0, 0. But since I'm shifting it right 1 and then down 9, wherever I end up is going to be my new vertex. So in this case, right 1, down 9. I'm plotting it on the graph. That'll be my new vertex, which is the point 1, negative 9. Alright, and actually I can find a lot of the rest of this information without my calculator. Because if I know the vertex, I know my axis of symmetry. It's x equals, and then this first number in my vertex. So in other words, it's this line right here, x equals 1. That's my axis of symmetry. Alright, and then local mins, local maxes. Well, let's think about what this graph is going to look like when I eventually draw it. For these, it helps to know which way it's going to open. So in this case, because there's no reflection, that's how I know which way it opens. No reflection means it's going to open up. So something like this. And if it opens up like this, that means the vertex is going to be a minimum. Alright, so when it says local minimum, I don't have to find some new point. My vertex is my local minimum, so I'm just going to write that point down again. Okay, as for local max, look at this graph. There's not going to be any maximums, so I would just write none. Now, absolute min, this is the absolute lowest this graph is ever going to be. So I would write down that vertex, that minimum, for my absolute min also. But once again, there's no maximums. That means there's no absolute maximums. Alright, so this information, A through G, everything in between, that's all done without a calculator. Alright, once we get to part H, then we're going to need a calculator because we don't know how to find the x-intercepts when we're in vertex form. We only know how to find the vertex. So I'm going to pull my calculator out and type this in. I'm going to go to my y equals, and I'm going to type the equation in. So parentheses x minus 1, close parentheses, squared, minus 9. And I'll graph it. Alright, so I know that's eventually what it's going to look like, but I need some points. I can't just roughly sketch that. So I'm going to find my x-intercepts. Remember, that's in second trace, and it's 0. 0 are our x-intercepts, so I'm going to choose number 2. And I'm going to pick this one on the left first, so I'm going to go as close as I can to it. And then I'll go a little bit farther left. And I'll press enter, and then I'll go back to it. And I'll go a little bit farther right and press enter, and then I can just press enter on guess. 0 is an x-intercept, so this point, negative 2, 0, is one of my x-intercepts, and I'll plot it on here. Okay, now there is another one, so I would have to go through that same process, but this time I would have to move over to my other x-intercept. If you want a shortcut so that you don't have to keep scrolling, you could actually type in a left boundary. For example, this x-intercept looks like it's 1, 2, 3, 4, about 4. So a left boundary could be the number to the left of it, so 3. So I could actually type in 3 and press enter, and it'll accept that as my left bound. For my right bound, I could pick a number to the right of it, like let's say 5, and it'll accept that as my right bound. Just another option for you. On guess, I would still press enter on guess, and there's my other 0. Okay, and I'll plot it on my graph. Same thing with the y-intercept. I'm going to use my calculator. I could do it by hand, but the calculator's probably a little faster. I'm going to use value and type in 0. So it'll be 0, negative 8. Okay, and now I have enough information to draw this graph, so I'm going to go ahead and sketch it out. There's one side, there's the other. And from there, I think we could get the rest of it on our own. Alright, if you need to check your answers, just take a look at the filled in notes on Canvas. Thanks for watching. I'll see you on Thursday.